Welcome to 7-6, Solving Multiple Step Inequalities. And here we're going to encounter variables on both sides of the inequality. We're going to see parentheses involved, something that we've seen before in previous chapters, but under the name of equations. So let's get started. This slide says that we must solve, check our solution, and then graph. So we have several things that we got to do in order to complete the directions. Well, I see here that I have 6x plus 15 is greater than 9. Just like an equation, I have a left side and a right side, where my inequality is the division of the two sides. I want to isolate the variable, like I would do, of course, in an equation. So I am going to look at the 15. I am going to use reverse PEMDAS. So that means I always do adding and subtracting first. In this case, I'm going to subtract 15 from both sides. The 15's cancel out. Leaves me with 6x is greater than negative 6. Notice that the negative 15 does not affect the inequality sign because it's adding and subtracting, and that has nothing to do with reversing our sign. Next step, I still haven't isolated my variable, so what I'm going to do is I'm going to use the inverse of multiplication, because 6x means 6 times x. So I'm going to divide, and whatever I want to do on one side I do on the other. The 6's cancel out, leaves me with just x is greater than negative 6 divided by 6 is negative 1. I believe that this is my answer, that all x's must be greater than negative 1. Before I do anything else, I want to check the format, and if you remember from previous lessons, the format is basically something like this, where I would want my variable first, I want my inequality, and then I want my answer or number coming last, and that does fit that. So let's go ahead and check our solution. What I need to do is look at what my answer is. I need an x that is greater than negative 1, so I'm going to choose something simple to use. I'm going to use 0. Then I'm going to go back to my original equation right here, the OG, and wherever there's an x, I am going to substitute that with a 0, or plug and chug. 6 times 0 is 0, so I'm left with 15 is greater than 9. That is a true statement. So I'm pretty sure that my answer is correct. The last thing to do, of course, is to graph it. Alright, so remember my graphing. I'm going to look at my answer. It's negative 1, so I'm going to make sure I put negative 1 on my line. I'm going to go ahead and put to the right side a 0, and to the left I'll put a negative 2. That's really all I need to have for graphing. Since my answer includes negative 1, I want to tell everyone we're going to start at negative 1. I'm going to keep it an open circle because that's what less than or greater than signs have. And I am going to make my arrow to the right. So what is my graph saying? It says that all my answers for x start at 0, but since it's an open circle, it doesn't include negative 1. And all the numbers to the right. Notice that this does look like my greater than sign right here. This right here looks like my greater than sign. So I know that my arrow is going in the right direction. Alright, we're going to solve, again, check our solution, and then graph it. This multi-step inequality has variables on both sides. My first step is to bring all the variables to one side. And I'm just going to go ahead and start off with moving the 2a. I'm going to subtract the 2a. Whatever I do on one side, I'll do on the other. Remembering that this is the left and right side because of the inequality divides it. By subtracting the 2a, that cancels out. Now I have 10. And negative 3 and a negative 2 combined together give me a negative 5a. The sign stays the same, and 25 is left on the right hand side. Now I want to isolate my variable. I am going to use reverse or inverse PEMDAS or backwards PEMDAS. I'm going to subtract the 10 from both sides. because that's the adding and subtracting. That cancels out. That leaves me with a negative 5x is less than or equal to, and the difference of 25 and 10 is 15. Alright, I'm going to go ahead and continue on trying to isolate my variable. I notice that I have a negative 5 being multiplied by the a, so the inverse of that is division. I'm going to divide by the same number that I have next to the a, which is a negative 5. But whatever I do on one side, I do the other. Alright, and this comes into where I have to remind you of the rule that whenever we're dividing or multiplying, and we do that by a negative number, our sign, our inequality, must reverse. We can go ahead and do the math. Negative 5 divided by negative 5 is a positive 1, or just 1a. And 15 divided by a negative 5 is a negative 3. And I assume that is my answer. The format checks. So I'm going to go ahead and now check my solution. Alright, since I think my answer should be any number that is greater than or equal to negative 3, I'm just going to go ahead and say a is equal to 5. Normally I pick 0, but let's just try something new. So I go back to the original equation. Wherever there's a, I substitute for 5, because 5 is greater than negative 3. And let's see here, 25 plus 2 times 5. And right here we have 10 minus 15. 10 minus 15 is negative 5. 25 plus 10. Well, that's 35. I'll bring down the sign. Is negative 5 less than 35? The answer is true. So I'm pretty sure this is my answer. Now all I have to do is graph it on a number line. Since I do believe my answer starts with a negative 3, I'm going to go ahead and create my number line, keeping it simple. That's all I need to know to demonstrate my answer. Because I have a greater than or equal sign, I am going to use not only a circle, but a closed circle to represent that sign. And then notice that the point, or my greater than, is pointing to the right. Kind of looks exactly like my answer, the greater than sign right here. So that means I know I'm doing it right. I'm going to go ahead and shade, show everyone. What does this graph say? It says that the answer includes negative 3 and all the numbers to the right of it. Alright, what we have here is a multiset inequality where it requires us to do the distributive property, where I'm going to go ahead and distribute the half. I'm going to use multiplication, and this will get rid of the parentheses, and that's the first thing I needed to do. Half of 2 is 1, so I get D. Half of 3, well, that's 1/2 times 3 over 1. Let's see here, that's 3 halves. Is that going to be less than negative 8? Well, let's find out. I do have my variable to isolate. I am going to use the backwards PEMDAS, so I'm going to get rid of the 3 over 2. Notice I didn't change it into a mixed number. I don't need to do that until the very end. So I'm going to go ahead and subtract negative 3 over 2. That leaves me with D on the left side is less than. If need be, I'm going to go ahead and calculate this. You can use your calculator, or you can do it by hand. The answer is negative 9.5. My answer is in the correct format, where it's a variable, inequality, and my answer. I just need to go ahead and check that, so let's go ahead and check it. I need a D that is less than negative 9.5. So negative 10 is less than negative 9.5. I'll go ahead and plug it into the OG, or the original equation. So where there's a D, I'll put a negative 10. And we're going to go see if this makes the statement true or false. let's see, 1/2, and that's negative 20 plus 3. It's 1/2 negative 17. Finally, 1/2 negative 17. I'm going to go ahead and use my calculator. I get negative 8.5. Is that less than a negative 8? Yes, that is true. So, since it's true, I do believe my answer is correct. All I got to do now is graph it. Since I have a fraction or a mixed number, I'm going to go ahead to make sure that I graph this correctly. I'm going to use, of course, negative 10 and negative 9 because my answer lies in between the two. Negative 9.5 I do believe is somewhere right about here. I use an open circle because it's a less than, doesn't have an equal sign. And if you can notice that my arrow of my answer is pointing to the left. So what does it say? It says that all my answers for D start at negative 9.5 and are to the left of that number, but do not include it. All right, let's see if we can use what we just learned in a word problem. Dante's telephone company charges $10 a month plus 5 cents for every minute or part of a minute. Dante wants his monthly bill to be under 30. What is the greatest number of minutes he can talk? So we know that he has a monthly charge. There we go. Plus he has a minute charge, and that's his cost. So what does he want? He wants his cost, when compared to 30, he wants it less than 30. He doesn't want it equal. He wants to be under $30. Well, some things we need to know is that how many minutes. So N is going to represent what we don't know, which is the number of minutes he's going to be on the phone. But we do know to find the cost, we're going to take 5 cents and multiply it by the number of minutes. And that will give us part of our cost, which is this cost right here. So we do know what the monthly charge is. It's 10 plus 5 cents per minute. So we're going to times that. And Dante wants it less than $30. We're going to go ahead and isolate the N here. So we're going to do backwards PEMDAS, get rid of the 10 before we do anything about this multiplication. I'm up at the point 0.05 times N is less than 20. Now I'm going to go ahead and get the N by itself by dividing by the same number that is connected to the N, which is 0.05 or 5 cents. Whatever I do on one side, I do to the other. No need to reverse the signs because we are dividing by a positive number. This cancels out. I get N is less than, and 20 divided by 0.05 is 400. Well, we need a number that is less than 400, but he wants the greatest. So how close can we get to 400? Well, you think I can get close to 100 by doing 399 minutes. That's the closest that we're going to get.